So why are the universities around the world interested in CDIO? Why is it that they all want to adopt CDIO? Okay, I think one of it is that looking at what is happening in engineering education for the past few years or for many years, we find that from a practice, engineering being a practice, it has more and more become more a theoretical program. So what CDIO is trying to do is, as what you said here, trying to make them more industry-oriented, give them more experiential learning related to what will be done in the industry. So more into the practice, or rather a balance between the practice and the theory. Okay? So that's what they found. Now, why is this important? It's because the feedback from industry, from graduates who join the industry, and from engineers, they find that certain professional skills are not developed in their existing curriculum. Okay? So part of the reason why CDIO came up is, what are these skills that we need to develop in our graduates so that the industry would find them useful? And I remember attending a meeting where Ed Crawley was there, he's the founder, and we had around the table Boeing, Bombardier, all the big aviation company. And they were using the CDIO framework to say, how can we prepare new entrants, they call it new entrants into the aviation industry. Okay, so they were saying, let's look at what are the skills that our new entrants into the aviation industry must have. Yeah? So they were looking at that. For us also, we asked our questions, is our engineering education meeting standards? Standards for us in Singapore set by our Institute of Engineers Singapore, for example, standards set by accreditation bodies like ABAT or the Engineers Ireland. I don't know whether you have standards here in Thailand that your professional body set. Do you have that? Not yet, coming. Coming. Yeah. So what are these standards? How are we meeting these standards? Okay, in our curriculum. And finally, what we as institutions and as individual lecturers want our standards, our students to achieve at the end of the day. How do we, what's our vision for our own students? All right? So for us, for CDIO, this big goal that we have, okay, the big goal, at the end of it, at the end of my program, at the end of the 4 years my students are with me, they should master technical fundamentals with a good understanding. That's key. You cannot be an engineer without knowing engineering fundamentals. So that's the first one. Secondly, because they're going out to be engineers, for example, what is it that engineers do? So if we really ask ourselves that, and you boil it down to its fundamentals, engineers conceive. Product engineers, right? Design engineers conceive, design, they implement, they operate. Okay, so here we say we want our engineers, our graduates to be able to create, to be able to operate new products, new processes, new systems. Okay, and finally, we want our students, when they leave, to know their impact on society, on environment, in their roles as an engineer. And this is where ethics, sustainability comes in. So in CDIO, it was very interesting. When it first came out, the leaders had to admit sustainability, environmental impact was not high on their priority list. But currently, they know there's something that has to be taken care of. And therefore, there's one thing that we are now strengthening in the CDIO framework. So if you attend our conference, many of you find that many MIT included are looking at how we could prepare our students and imbue in them the sense of knowing their impact on society and being ethical in their professional decisions. Okay? So these are the three, and this is the key. If you have that in mind, they must know fundamentals. That's key. You can't be a good engineer without knowing that. Okay, second one, they must know how to create, operate new products. And that, to us in Singapore, is very important. Because for us, innovation is what we want and what we are trying to develop in our students, to be innovative. Yeah? So to be new products, new processes, new systems, and then their impact on society. So what is CDIO? I think you all know. Conceive, to be able to define real-world problems. Design, know how to approach a problem and outline possible solutions. Implement, apply the possible solutions, and operate, optimize, improve the final product. Determine the life cycle. Okay, so it's very much an engineering cycle. Okay, CDIO has two key documents, just two. One is a syllabus, and one is the standards. Okay, the syllabus tells us what knowledge, skills, and attitudes that our students should learn. What are the key knowledge and attitudes? Okay, so there are 4 parts to the syllabus. The question I guess I ask is, who? Where did this syllabus come from? Okay, so when they started out, they actually surveyed the industry, surveyed faculty, surveyed new graduates, surveyed practicing engineers, and asked themselves, what is it that a graduate should have, an engineering graduate should have? So society, employers, students, faculty. Okay, so what is it engineering graduates should have? So these are the what that came out, the syllabus. There are 4 parts to it. The first one is disciplinary knowledge and reasoning. Knowing what are the fundamentals and how to reason through it. Then it's the personal and interpersonal skills like analytical reasoning, experimentation, investigation, knowledge discovery, systems thinking, ethics and responsibility. Communication skills, as mentioned earlier on, comm skills, and knowing what society, impact on society, environment, business, knowing the business context in which they work with, as well as the CDIO. Be able to conceive, design, implement, and operate. They're all together, besides the fundamental here, 13 skills. 13 skills. Okay? So we move a little bit forward and we ask ourselves, oh boy, now I have to, if I were to design my curriculum, do I need to put all 13 skills into my curriculum? Yes or no? Is that a lot to do? Yes? Yes, it is. It is a lot. Okay? So one thing you could do, and I think I was talking to Professor Mana, was do an industry survey. Go and ask those who matter most to you, how important are these 13 skills? And then from there, you will be able to surface 3, 4, 5, and you decide which of these 3, which of these 5, which of these 13 is important for my curriculum, for my program. Maybe not all, I don't need all 13, maybe I just need some. For us, we tell ourselves, if we can get 3 done, and 3 done well, very good. And one of it we're really focusing on is, as what you just said, comm skills, communication skills. To be able to get our students to be able to stand confidently, to talk confidently to whoever they're talking to, the boss, the client, a layman, whoever. Yeah. One of them is really, the other one for us is innovation. Thinking, creative, critical thinking, innovation, 2. Yeah, 2 key ones first at the moment. And the third one is learning to learn, yeah, or motivation, yeah.
Could you repeat that again?
Yeah.
Because I thought all of these come from stakeholders.
Yes.
You said, do we put all into the
Yes.
program?
Yes.
And I said yes.
Yeah.
And then the next step is to ask the stakeholder again.
Yes.
To put the priority on that.
Yes. Okay, what I'm doing here is managing your workload. Because like for us, we are so busy.
Right.
Yes? And we said, if I were to put all 13 skills into my curriculum, it is too much for one person to do. Okay? So a decision has to be made to manage that. Don't forget that this is not going to happen tomorrow or day after. You will come back to it. So like for us, the first round, we took 3 skills in year 1. Then we added another 2 skills in year 2. Then we added some more skills in year 3. So you keep coming back because as you progress, you find that, hey, this is now important. I should put it in. And let's see where I can put it in. So you don't have to make changes all at one go. You come back and you come back to it. It's a continuous improvement. Yeah? Otherwise, for us, I know my own colleagues will all give up. If you say do 13 skills, they all give up. First thing they say is, Helene, I don't want to do this, it's all right. Let me just stay at the sideline, you just go ahead and, and so forth. So we need to also know that we are very busy people, we've got a lot of stuff. Let's manage it. Let's not try to do too much. Let's take small steps. Okay? Yeah. So to be able to decide what should be the first skills, the first few skills that you implement, I would say go and ask people who are important to you. It could be industry, and industry will come back, I want comm skills perhaps. Yeah? And so forth. Yeah? These are the standards. So there are about 12 standards. There are 12 standards. The first one is adopt CDIO as a context. Now this is very interesting. What do we mean by that? Adopt CDIO as a context. Okay, so when you look at it, let's ask ourselves this question. If you were to teach someone to swim, okay, can you do it in a classroom like this? Cannot, right? You have to take that person to swimming pool, right, to swim. So similarly, when we say, you want to nurture an engineer, can you do it in a setting like this? No, right? You have to take them to a place where they can practice being an engineer. Okay, first step, right? So that's the context. Second thing, when you teach someone to swim, what does that mean? You have to teach them the strokes, right? To be able to float, to be able to move your arms, your legs, and so forth, right? So if you're going to prepare an engineer, then you have to teach the engineer the strokes as well. So what are these strokes? The strokes are to be able to conceive, if you look at it, as an engineer, depending on what type of engineer you are, conceive, to design, to implement, and operate. So that's what they're saying here, standard 1. So now we go back to our curriculum. So what does that look like in our curriculum? So our curriculum should then take into consideration what are the skills or the learning experiences that we need to give to our students so that we can prepare them to be better engineers. What is the context? Less of this, more of where they are practicing what they need to practice, thinking about what they need to think about, applying what they need to be applying. Yeah? So let's give them the context where they can do that. The second second one is then writing your syllabus outcomes. I think here, I believe you all went into OBE, am I right? Outcome-based education. So this would have been done already. You do have your syllabus outcomes of what you want to achieve. So that's fine. Then the next one, this is where I find a little bit interesting, because for us, before we started on CDIO, each of us were teaching our own course by ourselves, alone and not interacting with another course. Okay, but we all know that in engineering, can you just know thermodynamics, or can you just know CAD/CAM without knowing assembly or fabrication or whatever? We know that in the real world, all these are all coming together. So that's where integrated curriculum comes in. How can we show our students the links? The links that, the subject I teach is linked to the subject someone else is teaching. And how that looks like in the real world. Okay, and the subject he's teaching, how this tree comes together in the real world. All right, so that's where integrated curriculum comes in, and Chiwai will share with you what we do. The next one, standard 4, is Introduction to Engineering. I don't know about you, but in Singapore, many of our students join engineering not because they want to be engineers, they're there because it is not their first choice. They actually got 12 choices, and engineering is about the third choice, fourth choice, fifth choice, sixth choice, I don't know. What? Which choice?
First choice is very low.
Yeah, first choice, very low. It's not their first choice to be in engineering, okay? So, it's not their first choice. Secondly, they just put it on a list because they have to put 12 things down, and they come to engineering not knowing what engineering is about. So they're in the class, hey, teacher, what's engineering? And our younger generation, they're more used to sitting at the computer, playing computer games, than to disassembling things, investigating what's inside things, putting things together, building things. They don't do that. So that's one thing. They lack personal experiences in building, in designing, in implementing things. So the Introduction to Engineering is a course that most of the programs have. Most universities, if you look around in all the universities, most of them have that. The reason is that they want to introduce to the student, what is this world of engineering? It is an exciting world. It's something that impacts everybody. And what do you do? What do you find out? What's inside? What's, when you disassemble something and see how things all come together. They want to introduce to the student what is engineering and give them a little taste to be engineers in the first year. We know that many of our universities introduce the practice of engineering more in the final years. We said, let's bring it down to the first year and let the students get excited from the first year about engineering. Okay? Finally, design build, to give the students the opportunity or the experience to build something. All right, so some projects. Workspaces, so this is related to the first one, context. We want to put them in a context where they're conceiving, designing, implementing, operating. What does our workspace need to look like? And how can we redesign our workspace to encourage conceiving, designing, and so forth? What learning experiences can we give? This is related to the integrated curriculum. Once we start to integrate our curriculum and show students the links, can we give them experiences where they can experience the links for themselves so that it makes a better impression that, hey, yes, this is linked to this, and that's how it looks like in the real world. Active learning. I think active learning is really related to knowing how to learn. It's only when you get your students to do the learning themselves that they realize that they have to how to analyze, how to make sense, how to synthesize, how to report back. Active learning. It's also related to getting students more interested. Because once they conclude